It begins in silence. The kind of silence that only deep space facilities know, where the hum of machines replaces conversation, and the air seems to vibrate with invisible information. At NASA's Jet Propulsion Laboratory, midnight is not an ending but a continuation. Screens cast pale light over empty desks, and somewhere down a narrow corridor, a printer sighs to life. Paper feeds through with a soft mechanical whisper. The document is routine, or it should be. But across its header glows a quiet urgency. Confidential, internal memorandum. Timestamp, 2:37 a.m.m. Subject line, anomalous object entering the Jovian corridor. In the dim room, a technician leans closer to the screen. The memo isn't part of her scheduled task queue. She scrolls once, pauses, and then again. The lines are sparse, precise, sterile. Preliminary trajectory consistent with interstellar origin. Estimated mass exceeds Jovian moon Ganymede. Object not gravitationally bound to the sun. The cursor blinks. The silence deepens. Outside, Pasadena sleeps beneath a faint orange haze, unaware that within this quiet lab, someone has just read the first whisper of something vast. A coffee mug trembles as another night shift analyst joins the technician, drawn by the same soft alarm that hums in her chest. They stare together, two humans facing data that defies their experience. Rogue planetary object, the memo calls it. 3 words that turn the familiar sky into an unfinished question. Across monitors, code lines flicker and stabilize. A small red icon marks restricted access. The file closes on its own, encrypted again by automated protocol. But for a brief heartbeat, its contents ripple outward, downloaded, cached, mirrored in secondary terminals. Somewhere, an unseen relay saves it, and the information begins to spread like light through water. 1,000 miles away, at the Deep Space Network antenna in Canberra, a signal technician notes a faint pattern in the telemetry, numbers just out of place. At first, she dismisses it as instrument noise, the hum of cosmic background radiation. But the numbers repeat and something inside her says, check again. Imagine standing in that room. The air is cool metallic. The floor vibrates faintly from distant cooling systems. Outside, the night bends under the southern stars, and the massive dish antenna turns toward Jupiter, as if listening for a secret only the planet can hear. If you're listening to this as you drift toward sleep, that's exactly why these stories exist. Subscribe and tell me where you are and what time it is. I read them. New York at midnight, London before dawn, Sydney in the afternoon, like a constellation of listeners scattered across Earth, connected by the same quiet wonder. The signal intensifies. Tiny variations emerge in the static. A low hum oscillating around 1420 MHz, the hydrogen line, the universal frequency of cosmic communication. Yet it's not a message, not exactly. It's a movement, a presence, something entering the domain of Jupiter, as if crossing a boundary written only in gravity. Inside NASA's sealed network, simulations begin to run automatically. Thousands of digital suns and planets swirl on screen in slow motion, trying to predict what happens when an unbound mass drifts this close to our solar family. One model shows a stable pass, another shows orbital distortion, a third ends in collision. None match the data. The object isn't following an arc. It's gliding. Almost deliberate. There are whispers, between engineers, between research partners, across encrypted chat rooms. Someone recalls the last time an anomaly crossed our neighborhood. Oumuamua, the cigar-shaped visitor that came from another star. But this is different. It's not small, not harmless. And it isn't leaving. By dawn, the memo has reached higher clearance levels. Senior astronomers in Houston, Pasadena, and Madrid receive soft pings on secure devices. The subject line now reads, follow-up required, possible gravitational perturbation detected. The wording is gentle, procedural. But every scientist who reads it feels the same pulse of unease. Through the day, radio telescopes across the world realign, slow, deliberate motions that seem almost reverent. In the Atacama Desert, the great dishes turn their silver faces toward Jupiter's path, tracing a thread of invisible motion through the dark. In Hawaii, the Keck Observatory adjusts its mirrors, catching photons that left the object nearly an hour ago. If you could stand beneath those telescopes, you'd hear nothing but wind and the faint click of servos adjusting mirrors finer than a human hair. Above you, Jupiter gleams like a pale lantern suspended in a cradle of silence. Somewhere beyond that glowing giant, a black shape moves, featureless, without atmosphere, cold enough to silence light itself. NASA's analysts gather in a low-lit room. On the wall, data streams across massive panels. Orbital plots, density estimates, magnetosphere predictions. One line stands out, highlighted in yellow: origin uncertain. Possible interstellar trajectory. The phrase possible interstellar is both thrilling and terrifying. Interstellar means not from here, not from the quiet garden of planets we call home, but from the endless cold between stars. It means something ancient, older than our sun, now brushing against the edges of our cosmic doorstep. The narrator's tone softens. You can almost hear the gentle thrum of processors, the shuffle of papers, the soft click of a pen tapping against a notebook. Someone in that room finally asks, "When was it first seen?" No one answers. Because no one knows. Some data packets hint that the anomaly may have appeared in earlier sky surveys, tiny, unnoticed blips buried in terabytes of imagery. But those archives are decades old, captured on hardware that no longer exists. The past becomes a fog, and inside it, the first appearance hides like a shadow behind the stars. Our stretch. The object moves another fraction of a degree closer to Jupiter's path. Someone calculates its estimated arrival window: 12 months, maybe less. Yet despite the urgency, the mood remains calm, like standing on the shore watching a tide you can't stop. In public, nothing changes. The world sleeps. The memo never leaves the classified directory. Its existence becomes rumor, then silence. But deep within NASA's networks, something stirs. A system labeled Spectral Analysis Group B requests remote access to multiple observatories at once. The code is automated, the purpose unknown. And above the blue world of Earth, satellites shift their attention slightly, small antenna arrays pivoting toward Jupiter's golden light. What exactly are they listening for? Hours later, when the last night shift worker leaves the lab, a single monitor remains lit. Across its surface drifts a slow scan of space, bright points of light forming patterns only algorithms can read. The rogue object, whatever it is, appears again. Fainter this time, but closer. The narrator's voice becomes soft, almost a whisper now. Facts blur with whispers, it says. And whispers become gravity. Outside, dawn filters through thin clouds, tinting the windows with a faint orange glow. The city stirs to life, unaware that something vast is moving silently across the dark ocean of space, an unseen traveler brushing past Jupiter's orbit, rewriting the margins of our solar story. And as the telescopes realign once more, the question hangs like mist above their domes. What exactly did NASA's scientists see moving toward Jupiter's light? The silence deepened, yet hidden in that silence was something waiting to be understood. It began, as many great cosmic stories do, with something that did not fit. Late one quiet evening, a faint discrepancy appeared in the Pan-STARRS 2 telescope's nightly survey, a pixel of light that refused to behave like anything in its catalog. Most observers might have dismissed it as noise, a reflection, or a camera artifact. But this pixel moved. Slowly. Consistently. And most strangely of all, it did not belong to any known orbit around the Sun. The telescope's sensors, nested high on the summit of Haleakala in Hawaii, swept the night like a gentle brush across canvas. Amid millions of dots, this one glowed a shade dimmer, almost shy, its motion tracing no familiar curve through the sky. Algorithms compared it to comets, to asteroids, to debris trails. Each comparison failed. Whatever it was, it drifted free, a visitor from beyond the gravitational fortress that binds the planets. Astronomers gathered in small, focused circles, speaking in low tones beneath red lights. They pulled data from previous nights and rewound the sky like a film reel. The same faint traveler appeared again, sliding between the fixed stars. No tail, no outgassing jets. Just a silent wanderer, slipping through darkness. Its brightness barely changed, suggesting a surface smooth and cold, perhaps metallic, perhaps frozen. When plotted, its trajectory did not loop or spiral. It was a straight line, a quiet declaration of independence from the Sun. The object seemed unbound by gravity itself, as if it had been born elsewhere, somewhere beyond the far curtain of the Kuiper Belt, or farther still, past the heliopause where the solar wind dissolves into interstellar space. To those who studied orbital mechanics, the discovery was intoxicating. Here was a rogue world, a body that had escaped its star's grasp and wandered through the galaxy like a ship without a harbor. Estimates of its size varied, from something smaller than a moon to something vast enough to eclipse a small planet. But what unsettled the observers most was its composure. It neither accelerated nor slowed, as though the emptiness between suns were its natural home. Each new measurement deepened the enigma. Its reflected starlight carried odd signatures, tiny shifts in wavelength that refused to align with known minerals or gases. Spectrographs showed faint traces of carbon monoxide and ionized hydrogen, but in patterns too irregular to classify. Some suggested interference, others suspected instrument error. Yet the readings repeated, night after night, unwavering. The story unfolded with a softness that belied its magnitude. Reports were filed. Private channels hummed with cautious speculation. Could this be an orphan planet ejected from a distant solar system? A fragment of a shattered star? Or something older, carved by physics we do not yet understand? The narrator's tone, if you could hear it, would be low and steady, the way voices sound inside observatories at 3 a.m. You can almost picture them. The scientists leaning over keyboards, their faces lit in blue, the desert air humming outside. A moth taps against the window. Beyond that glass, light born centuries ago crosses the void to fall into human eyes for the very first time. As more data arrived, subtle gravitational whispers began to ripple through predictions of Jupiter's magnetic environment. Tiny variations, so small they could have been noise, appeared in the models. But the timing matched. Whatever this traveler was, its path brushed close enough to the solar system's largest planet to leave a fingerprint. Imagine standing beneath a night sky, tracing that invisible route in your mind. Somewhere out there, a dark shape glides across starlight. No engine, no flare, no voice, only momentum. Its motion feels deliberate, but perhaps that's only the mind searching for meaning in the stillness. Pan-STARRS 2 kept its gaze steady. Night after night, the telescope gathered photons like whispers, translating them into numbers and numbers into stories. The anomaly moved closer to the heliocentric frame, but never toward the sun itself. More like a guest cutting across the edge of a grand ballroom, content to remain unseen by the dancers inside. Some within NASA began referring to it informally as the Traveler. Not a code name, not an official classification, just a word that captured both distance and mystery. The Traveler was not a comet, not an asteroid, not a meteor fragment. Its path through the ecliptic was too high, its angle too severe. It was a thing between categories, an outsider in a universe of patterns. As data accumulated, software attempted to fit it into the familiar language of orbital arcs. Every model failed within days. Each predicted position drifted, as if the object refused to be graphed. Its apparent magnitude flickered gently, but not enough to suggest rotation. It gave no radio echo, no thermal glow, only reflected sunlight, dull and steady. The astronomers spoke of it with growing affection, the way sailors once spoke of distant lights on the sea. They admired its indifference, its patience. Some nights, they would watch the horizon glow faintly with dawn and feel an ache of recognition, because this object, unbound and silent, represented something deeply human, the desire to keep moving even when no one is watching. There were debates, of course. One faction argued for natural origins. A rogue planet cast adrift after a gravitational encounter billions of years ago. Another whispered about relics, ancient debris from a dead system, or even the shell of something once alive. Yet most agreed on one truth: it was older than anything orbiting our sun. When Jupiter's magnetic field began showing measurable fluctuations, minute, almost imperceptible changes in its radio output, the connection was impossible to ignore. Instruments recorded a faint increase in decametric emissions, the kind generated when charged particles danced through magnetic lines. To the untrained ear it sounded like static. To those who listened closely it sounded like rhythm. For weeks the traveler drifted closer. No collision course, no threat, just proximity. The giant planet's gravity would bend its path slightly, a graceful curve through invisible currents. Around that time a few scientists noted something else. A delicate shimmer in ultraviolet photographs, as though sunlight was scattering off a thin, uneven surface. Dust, perhaps, or frozen gas forming a halo. In the language of space, such details are everything. A shimmer can reveal history, a wobble can imply structure. The traveler's faint veil might have been nothing more than interstellar frost evaporating in the sun's distant warmth. Or it might have been something no one could yet define. A sheath, a cocoon, a field of particles orbiting a hidden core. As the weeks passed, the object became a quiet obsession. People stopped asking whether it was dangerous and began asking what it was trying to tell them, even if they didn't believe it could speak. There is a certain humility in realizing the universe does not need an audience, and yet it performs all the same. The final nights of observation before it moved beyond range were the most haunting. The traveler's trajectory aligned against the backdrop of Jupiter's glow, a dark thread passing through a sea of gold and amber clouds. For a moment, telescopes caught the faintest silhouette, a pinprick shadow moving across the limb of the planet. Then nothing. The data stream steadied, empty once more. Astronomers compared timestamps, recalculated distances, and waited for confirmation. The magnetic anomalies subsided. Jupiter resumed its rhythm. But the image of that wandering world lingered, an ancient traveler gliding between stars, unseen except by those who watched in silence. And though the sky had returned to normal, no one who had witnessed those readings could quite forget the feeling that lingered afterward, that something older than planets themselves had drifted through our neighborhood, paused for a breath, and continued on its way, leaving behind a question that no equation could yet answer. The night sky once again belonged to the ordinary lights of Jupiter and its moons. But somewhere beyond their glow, in the cradle of silence, a shadow kept moving. Whether it was stone, ice, or memory, no one could say. Only that it had passed, and the silence deepened, yet hidden in that silence was something waiting to be understood. ChatGPT can make mistakes. Check important info. The control room is quiet, so quiet that even the soft clicking of a keyboard feels like a heartbeat in the dark. Rows of monitors glow with shifting constellations of code, graphs, and faint light curves from distant stars. Somewhere among them, hidden in petabytes of raw observation logs, lies a pattern, a whisper in the data that shouldn't exist. Scientists sit beneath the pale hum of fluorescent lights, their faces reflected in the screens as though peering into parallel worlds. For hours, they stare at dots that blink and fade, at lines that should be smooth but tremble slightly, at readings that behave like the pulse of something alive. Each pixel tells part of a story, but together they form a silence deeper than language, a silence filled with meaning. Jupiter looms large in the background of their simulations, its gravity bending paths like invisible fingers curling through space. The numbers tell them something is moving there, close enough to disturb the outermost arcs of its magnetosphere, yet somehow invisible to reflected light. It's as if the object drinks starlight rather than reflecting it. One researcher, a woman named Keller, zooms into a faint variation in starlight, a dip lasting barely 3 seconds. "There," she murmurs. The others gather. The room tightens. Someone increases the contrast. The signal appears again, weaker but rhythmic, like a slow breath. It repeats every 41 hours, steady as tides. A planet's rotation? A shadow? Or an echo of interference from the sun's charged wind? They compare datasets from Chile, Hawaii, and Canary Islands observatories. The anomaly persists. The same whisper, the same faint dimming, traveling across multiple instruments. The only conclusion: it's real. But what it represents, no one can say. In the next room, servers drone, a low, endless hum that seems to merge with Jupiter's faint radio hiss captured by deep space antennas. The scientists listen to those waves translated into sound, a soft static that rises and falls, almost musical, almost mournful. In that rhythm, they imagine the rogue object turning slowly in the void, a silent traveler cloaked in dust. Mathematically, it shouldn't be there. They model its trajectory, a parabolic curve that grazes Jupiter's orbital path but never settles into orbit. It's an intruder, slipping through like a shadow caught in gravity's web. The computer calculates its perihelion, too close to the sun to be stable, too shallow to be captured. It should have passed long ago. And yet, its presence still stirs Jupiter's outer magnetic tendrils. Keller runs another simulation, layering predicted drift over historical positions. The pattern doesn't match any known asteroid family or comet track. It behaves as if guided, not by propulsion, but by some ancient inertia that resists prediction. The object moves just enough to break the models, just enough to remind them that the universe still keeps secrets. In the soft glow of monitors, fatigue blends with awe. They sip lukewarm coffee, whisper theories, and watch digital orbits twirl in hypnotic slow motion. One analyst mentions that if the object truly emits no light, its surface might be coated in materials we don't understand. Carbon frozen with iron dust, perhaps, or exotic compounds from interstellar space. Another counters that it could be something hollow, absorbing radiation instead of reflecting it. The narrator's tone slows, calming, like breath on glass. Imagine staring into numbers until they become a face, a shape forming not in space but in thought. What if every equation is a mirror showing us what we most want to see? The scientists remain grounded, careful, skeptical. Yet something about the rhythm of that flicker unsettles them. It behaves too perfectly. Not chaotic, not natural. Still, there's no evidence of artificial design, just a pulse, steady and indifferent. Outside the control room, night settles over the desert. The telescopes tilt toward Jupiter's region, their domes opening like metallic petals. Air cools, stars sharpen against black. Inside the control center, the data stream thickens. Bytes of cosmic dust rendered as light. On screen, one data point brightens and then vanishes. The whisper again. A few of them stay behind after their shift ends. No one says it aloud, but they all feel it, that sense of being observed. As if the data itself is aware of being read. The graphs stretch like sound waves, the dips marking intervals of silence. Hours pass. They isolate a signature, too faint to call a signal, too regular to dismiss as noise. The team logs it under unexplained photometric variation. 3 words that sound calm but mean sleepless nights ahead. Keller reclines in her chair, eyes half closed. If it hides its own light, she says softly, maybe it doesn't want to be seen. The line lingers in the air like static before a transmission. The hum of servers deepens. Someone dims the lights further, and the entire room takes on the bluish tint of an underwater dream. Beyond those walls, Jupiter spins through the darkness, wrapped in storms and lightning that no human eye will ever witness directly. Somewhere near its magnetic frontier drifts the unseen traveler, silent, steady, indifferent to the watchers far away. The final logs of the night are archived, compressed, and stored in servers colder than ice. The scientists head home, their faces tired but luminous with curiosity. Above them, clouds part for a moment, revealing a single bright point, Jupiter itself, glinting low on the horizon. And perhaps, just beside it, a glimmer too faint to notice unless you knew exactly where to look. The narrator's voice drops to a whisper. If it hides its own light, what else is it hiding? The hum fades, the night grows still, and the silence feels almost alive, an endless cradle of stars holding one more secret, waiting to be understood. In the quiet ocean of space, Jupiter turns slowly, its immense form bathed in bands of amber and cream. Through the lenses of distant telescopes, the gas giant appears almost alive, its storms spinning in slow motion, each a vortex large enough to swallow Earth. The great red spot churns like an ancient scar, an endless cyclone that has raged for centuries. Lightning flickers deep within the clouds, silent to us, but bright enough to outshine a small city. And beyond that serene violence, a new shadow approaches. Astronomers trace its path carefully. A rogue planet, dark and cold, wandering through the void without a sun to call home. It is massive, heavier than expected, and its velocity betrays no stable orbit. Calculations show a trajectory threading close, dangerously close, to Jupiter's gravity well. Not a collision, perhaps, but near enough that the two giants will feel each other's pull like old titans meeting in silence. Inside NASA's simulation rooms, vast screens glow faintly in the dim. Lines of white trace the rogue's route, looping like threads around Jupiter's glowing disk. If it slips by at this angle, one scientist murmurs, it could alter its speed by millions of miles per hour. Another voice adds softly, or alter Jupiter's magnetosphere entirely. Yet there is no panic, only focus, the kind of stillness that comes when humans observe the inevitable. The narrator's voice lowers to a hush, describing the spectacle as if seen from above the solar system. Jupiter's auroras ignite, stretching thousands of miles across its poles. Curtains of blue and violet light shimmer against the black backdrop of space, flickering in long, silent waves. They look almost like breath, like the planet itself is exhaling in anticipation. The rogue moves closer, invisible except where it interrupts the background stars, a moving gap in the tapestry of light. From Earth, the event is distant but measurable. Instruments register subtle fluctuations in radio emissions, the rhythm of Jupiter's magnetic field bending ever so slightly. Amateur astronomers note a faint distortion near the gas giant's limb, a tiny ripple where light bends through invisible mass. To the human eye, it's nothing. To the machines, it's everything. For a moment, scientists allow themselves to imagine what could happen if the rogue wandered just a fraction closer. The gravitational ballet would turn chaotic. Moons could drift from their orbits, radiation belts might collapse into storms, and electric discharges could dance between the two worlds like cosmic lightning. Simulations show Jupiter's upper atmosphere glowing white-hot, a halo of plasma blooming around it, a brief, beautiful catastrophe frozen in mathematics. And yet, amid these projections there's a sense of calm. The voice of the narrator slows, almost like a lullaby. Imagine watching it all from the safety of distance, as though standing on a quiet cliff watching two oceans merge far below. The danger exists only in numbers, not in the silence that fills the real sky. To most people on Earth, it's just another night. Stars drift, winds on Jupiter rage, and somewhere out there, two worlds prepare for a meeting neither will remember. As the rogue draws near, new data begin to puzzle the observers. Its projected course shifts slightly, not much, just enough to be noticed. The deviation doesn't fit known gravitational models. Could it be reacting to Jupiter's magnetosphere? One astrophysicist wonders aloud. Perhaps, says another, but what if it's not reaction? What if it's intention? The words linger in the dim light. No one speaks for a while. Instead, they watch the monitor as the rogue's arc adjusts by a fraction of a degree. The room hums with machines and quiet breathing. Data streams flow like rivers of light. If it were an error, it would have corrected itself by now. But the new line, the one that curves just slightly wider, holds steady. The narrator describes the moment softly, as though not to disturb the cosmos itself. Out there, among giants, something unseen altered its path. Whether by chance or choice, no one can say. It's as if the void itself exhaled, nudging the traveler away. The shift is so subtle it defies easy explanation. Perhaps a burst of trapped hydrogen vented into space. Perhaps internal magnetic fields aligned just so. Or perhaps, impossibly, it responded to something. The auroras over Jupiter flare once more, brighter than before. Radio telescopes pick up a faint hum, a whispering interference pattern that vanishes as quickly as it appears. The data is logged, time-stamped, then dismissed as cosmic noise. But one in turn keeps listening to the playback. He swears he hears rhythm. Not constant, not random, something in between. He replays it again and again long after the others have gone home. Meanwhile, the rogue planet drifts onward, its silhouette now barely visible against Jupiter's golden bands. From our distance, the encounter looks like a dance of light and shadow. The gas giant glows, the rogue absorbs. One radiates life, the other carries silence. Their meeting lasts only hours, but for a moment, the balance of the solar system trembles, then holds. By dawn on Earth, the object has passed the point of greatest proximity. Jupiter remains intact, its storms rolling endlessly. The rogue continues along a new course, slightly altered, inexplicably so. Astronomers mark it in their logs with a cautious note: trajectory variance unexplained. And though the screens dim and the chatter fades, one thought stays behind, unspoken but shared. Among them all. If something without light, without orbit, and without anchor can change direction, what force whispered to it in the dark? The silence deepens, vast and serene, yet hidden in that silence is something waiting to be understood. It begins with the hum of fluorescent lights and the faint rustle of paper, a corridor deep within a federal complex where the air smells faintly of dust and ozone. At this hour, the offices are supposed to be empty. Yet behind one closed door, a handful of engineers huddle around a projection screen glowing pale blue, their reflections trembling across the metal blinds. On the screen, a set of coordinates blinks beside the words, "Planetary Motion Irregularities, Classified." They do not speak loudly. Every voice seems borrowed from the silence. Someone mentions gravitational drift near Jupiter's orbital corridor. Someone else slides a folder across the table. Inside it, a timestamp, 2:14 a.m. And beneath it, 3 signatures smudged into unreadable black ink. Outside, the night is still. The moon drifts over Pasadena. But inside NASA's secure wing, the calm hides tension so thin it hums. The engineers know what these numbers mean. A body of mass comparable to a small planet, moving with no solar leash, cutting across the heliocentric model like an uninvited guest. The data should have gone public through routine channels. It didn't. In a calm narrator's voice, we drift through the room. The Planetary Defense Coordination Office, created to track near-Earth hazards, wasn't even copied on this dataset. No alerts, no press briefings, no cross-agency coordination. Instead, the records are routed through special clearance servers, the kind normally reserved for nuclear satellite reentries or defense sensor anomalies. One retired systems analyst later remembers the memo's subject line: "Trajectory Divergence Event." A harmless phrase except for what followed: a directive ordering data, restricted from civilian dissemination pending further orbital refinement. That was bureaucratic code for seal it. The document vanished from public archives within days, overwritten by an update that never appeared on official logs. The narrator's tone remains calm, almost hypnotic, but every sentence carries weight. A soft electronic tone fades in, like the echo of telemetry lost to static. We imagine the scientists who signed their names to the discovery, now redacted. We imagine the quiet worry of those who knew and said nothing. Voyager's deep space data is revisited next. Buried within decades-old telemetry, there are records of minute gravitational fluctuations, unexplained even by Jupiter's immense pull. The logs are real, the patterns subtle, the kind of oddity that at the time would have been dismissed as noise. But someone somewhere connected them. And when they did, an internal message was circulated under emergency protocol. Its language was clinical: potential interstellar mass transiting Jovian periphery. Source uncertain. Monitoring recommended. Then came the red stamp: classified, internal eyes only. The calm narration slows, giving listeners time to breathe, to imagine the dim light of those rooms where information disappears not by destruction, but by redaction. Words blacked out. Names erased. Coordinates rewritten in shorthand indecipherable to the public. It's not cinematic in the sense of action. It's cinematic in restraint, the way secrets often are. Engineers whisper of disappearing files. Hard drives that log errors before being wiped. Entire server partitions labeled restricted _. Some of them remember losing access mid-shift, their credentials revoked without notice. And when they asked why, the answer was simple: maintenance. But maintenance does not explain erased optical backups or vanished lab notebooks. Over time, those who were there move on. A few retire, a few write memoirs, most stay silent. Yet fragments remain in technical forums, half-remembered comments hidden behind usernames. It wasn't an asteroid, one anonymous user posts. We were told it was a gravity modeling error. But the numbers didn't behave like an error, they behaved like intention. The narrator lets that word, intention, linger. Not claimed, not proven, just suspended like dust motes in a sunbeam. Slowly the story widens. The calm voice reminds us that NASA is not a monolith. It is a network of people, institutions, policies. Some act to prevent panic, others act to preserve integrity. And sometimes those motives collide. During the late 1990s, after a handful of premature doomsday claims, internal policy shifted. Information deemed potentially disruptive to public stability could be held for independent verification. It sounds reasonable, until one wonders who decides what qualifies as disruptive. In that gray space, secrecy thrives. The narrator's voice becomes softer now, inviting reflection rather than suspicion. Perhaps it was not conspiracy but caution. Perhaps the architects of secrecy believed they were protecting humanity from its own fear. History shows similar patterns. Chernobyl's delayed alerts, meteor detections held back until radar confirmation. Even the early Apollo accidents shielded until families could be notified. Silence, in bureaucratic language, often means time to breathe. But what if silence also means time to forget? In the background, the soft hum of Jupiter's magnetosphere recordings plays, a deep, natural sound like wine through metal reeds. The chapter moves between fact and atmosphere, exploring the psychology of secrecy. The engineers were not villains. They were custodians of uncertainty. They stood between discovery and chaos. And perhaps they realized that sometimes, knowledge can destabilize as surely as ignorance. A quote surfaces from an old mission director recorded decades later. If you find something that shouldn't exist, your first instinct isn't to publish, it's to check again. The danger isn't what's out there. It's what happens when everyone sees it at once. The narrator's tone grows quieter, as if afraid to disturb the air. Files disappear, the voice says, because people do not. They carry the knowledge forward, fragment by fragment, through memory, through fear, through the small decisions that shape history unseen. We drift across images, the glow of a server rack at midnight, a drawer closing on a sealed envelope, the faint scent of toner and static electricity. Somewhere in that quiet, the missing memo still exists, copied, hidden, or forgotten. Maybe it waits in a basement archive. Maybe it was shredded decades ago. Or maybe, as rumors suggest, it was never paper at all, just encrypted code transmitted once, then lost in the noise of the deep space network. The camera of imagination pulls back from those closed doors. The building shrinks beneath the stars. The Earth turns indifferent. Above, Jupiter continues its slow rotation, the red storm spinning like a patient eye. Whatever knowledge the engineers tried to bury, the cosmos does not pause. It keeps sending whispers, signals, motions too vast to censor. Was the secrecy to protect panic, or to hide discovery? The narrator doesn't answer. The voice only softens, wrapping the question in stillness. Outside, dawn begins to brush the edges of the planet with light. In the growing warmth, the hidden files remain in their quiet exile, waiting. And in that waiting, the silence deepens. Yet hidden in that silence is something still listening, something waiting to be understood. It begins not in the present, but in the soft amber light of the past, where the first whispers of a rogue world were not signals and data, but stories told beneath starlit skies. The narrator's tone is calm, slow, dreamlike. In 1983, a quiet hum from the infrared astronomical satellite, known as IRAS, reached Earth's scientists. Among its thousands of sky scans was one anomaly, a cluster of infrared heat that didn't belong to any known star or comet. Some called it a misreading, others a discovery that never made it past the filters of caution. For a few weeks, astronomers debated a possible new planetary body beyond Pluto, something vast and cold, drifting on a hidden trajectory. Then the files went still. The soundscape softens, replaced by the imagined tick of old observatory clocks and the shuffle of paper star maps. Long before infrared telescopes, ancient civilizations had already gazed upward, noticing strange wanderers among the fixed stars. In Mesopotamia, the Sumerians carved into clay tablets tales of Nibiru, the crossing planet. To them, it was a harbinger, an omen that brushed past Earth in cycles of destruction and renewal. Historians later dismissed it as myth, a poetic metaphor for eclipses or droughts. Yet the word Nibiru, the crossing, lingers like a fossilized fear buried inside the language of the sky. As centuries passed, the tools changed but the awe remained. The first telescopes of the 17th century trembled with candlelight, their lenses fogged by human breath and night dew. Astronomers scribbled coordinates by hand, each notation a promise that something vast might reveal itself. Through those fragile instruments, planets appeared as blurs of shimmering light, and comets as ghostly threads pulling across blackness. Each discovery carried equal parts wonder and unease. To find a new world was to ask, how long has it been watching us? The chapter's rhythm drifts slower now, like dust settling on glass. We hear of Percival Lowell, who once mapped faint irregularities in Neptune's orbit and became convinced of another unseen planet tugging from beyond. His Planet X turned out to be illusion, mathematical ghosts born of error, but his pursuit lit a torch that others carried for decades. Even when Pluto was found, it was too small to account for those gravitational whispers. Something larger, unseen, still haunted the equations. The narrator's voice lowers, blending nostalgia with quiet unease. By 1999, whispers returned. A forgotten internal memo, its authenticity debated, spoke of an unregistered celestial visitor, detected briefly by a military-grade telescope network. The words were cautious, clinical. Object appears to move counter to expected trajectories. Optical signature inconsistent with debris or cometary composition. The memo faded into the archives, dismissed as calibration error. Yet fragments survived, scanned pages with grainy timestamps, initials half erased by time. Between science and legend lies a fragile thread, the human need to give fear a name. From Nibiru to Planet X, from Iris to the unnamed memo, each era invents language to make the unknown less terrifying. We call them travelers, messengers, or omens not because we know them, but because we need them to mean something. The narration paints this sentiment with soft imagery, ink soaking into parchment, candle smoke rising like nebulae, the clatter of early computers humming through cold laboratory air. The scene shifts gently into sensory calm, the soft glow of telescope domes opening under a midnight wind, the hum of power lines stretching into distant hills. Beneath the silence, history feels cyclical, as though every century humanity rediscovers its own uncertainty. The rogue planet isn't just a body of rock and ice, it's a reflection of our repeating curiosity. We are drawn to anomalies because they remind us that certainty is fragile. The narrator pauses, letting the listener breathe. There's a hint of warmth, scientists laughing quietly over misread data, ancient priests whispering prayers to a star they could never touch. Across millennia, both seek the same comfort, to believe that the night sky has meaning. The calm tone carries a melancholy beauty, like the sound of distant thunder rolling over a sleeping world. And then, softly, almost like a lullaby, comes a thought. What if the myths were never wrong, just mistranslated by time? Maybe the stories of Nibiru weren't warnings, but early reports. Attempts to record something real, glimpsed in fleeting moments when the heavens shifted and fear took the shape of understanding. The narration slows further, dissolving into dreamlike stillness. Data, clay tablets, forgotten memos, all fragments of the same ancient instinct, to listen for footsteps in the cosmic dark. The IRAS blip of 1983, the Nibiru of antiquity, the unsigned memo of 1999, they may not share evidence, but they share intention. Each marks a point on humanity's long trajectory toward wonder. As the chapter closes, the imagery softens into timeless motion, telescopes turning like tired eyes, ink fading on brittle paper, stars sliding silently through their endless orbits. The voice lowers to a whisper, leaving a question suspended in the quiet. Perhaps the stories of old weren't prophecy or paranoia. Perhaps they were observation, spoken in a language we've just begun to remember. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. In the thin air above Chile's Atacama Desert, where the sky is so clear it feels almost carved from glass, a beam of light trembles against the cold. Here, under the highest plateau on Earth, a group of scientists watch the stars not with eyes, but with instruments sensitive enough to read whispers of color invisible to human sight. Tonight, that color does not belong to anything they know. Through the mirrored tubes of the spectrograph, the data spills across a monitor like a painting undone by some invisible hand. Instead of the steady, predictable lines of a gas giant, cold, methane blue, and faint, the new reading blooms with sharp traces of ionized hydrogen and something metallic shimmering in the red. It should not be there. A world drifting so far from the sun should sleep in frozen silence. And yet, somewhere beyond Jupiter's watch, this stranger seems to burn. The lead researcher, her face lit by the faint cyan of the screen, murmurs that it looks like vapor, metallic vapor, streaming from fractures in an unseen atmosphere. She adjusts the focus, the data brightens, blurs, then steadies again. Around her, the observatory hums softly, like a breathing machine keeping the night alive. Each line of color carries a note, a temperature, a fingerprint of the unknown. They double-check the calibration. Nothing is wrong with the equipment. The same result appears again and again. The planet, if that's what it is, releases energy far too high for an object so far from the sun's warmth. The air grows still as though the desert itself is listening. In the dim light, a scientist compares the spectrum to known samples: sodium, magnesium, iron. The pattern matches none exactly. It's as if the rogue planet carries an alloy older than any we've cataloged, something that has seen different suns, forged under alien conditions. The colors are described in soft tones: a gold that hums faintly in data form, a blue that fades into ultraviolet, and a pale red that feels almost alive. Across the control room, someone laughs quietly, not from humor but disbelief. "It's painting," she whispers, "like it's painting its own reflection back at us." The narrator's voice slows, warm and rhythmic, carrying the listener closer. Imagine these colors as brushstrokes drifting across the void, faint pigments on the dark canvas of the universe. The rogue planet glides unseen, but the light it throws back is art. Untranslated, persistent, deliberate. For 3 nights they observe, and each night the spectrum changes slightly. A flare in the metallic band, a fading in hydrogen, and then a pulse. Not random static. Not noise. A soft repetition in brightness, steady, rhythmic, as if something inside that distant shadow is exhaling light. They overlay the readings with cosmic background radiation. The pulse cuts clean through the noise. 11 minutes apart. Too slow for a pulsar. Too structured for a flare. And far too consistent to be dismissed. The air around the monitors grows thick with the weight of what it could mean. One scientist traces the waveform with his finger, whispering that maybe it's a rotation signal. Something spinning, reflecting light as it turns. Another shakes her head. The angle doesn't fit, the intensity doesn't fade the way reflected light should. Whatever it is, it's stable, deliberate, repeating like a heartbeat. Outside, the desert wind drifts around the domes, a faint whisper of dust on steel. The Atacama is one of the driest places on Earth, a cradle of silence where sound seems to dissolve before it travels. And yet, in this quiet, a world hundreds of millions of miles away seems to be speaking through light. The narrator pauses, voice softening like a lullaby. Imagine standing there, wrapped in a blanket of cold air, looking up at a sky so still it almost feels alive. Somewhere in that endless darkness, something shines not to be seen, but to be noticed. Back inside, the team decides to share the data with another observatory across the world. Within hours, instruments in Hawaii confirm the same spectral anomaly. The rogue signature is real. Its light is faint but precise, like a signal meant only for those awake at the edge of night. Days pass. The readings persist. The pulse remains exact. Journal drafts circulate quietly under embargo. Words like intentional emission are replaced with unknown periodic phenomenon. Every scientist knows what that means. They just can't say it. One evening, as the sky deepens into indigo, the lead astronomer records her notes aloud. Her voice trembles between logic and wonder. It behaves like it knows we're watching. The statement hangs in the air, absurd and beautiful. No one replies. Some things are too delicate for laughter, too frightening for certainty. Later, as the observatory powers down for the night, Screens dim and the hum fades into silence. Only one light remains on, a small monitor still charting the pulse. 11 minutes, 47 seconds. Then again. As steady as breath. The narrator explains gently that such precision could come from magnetic convection or cryovolcanic venting. Natural processes capable of rhythm. Yet, deep down, everyone knows nature rarely keeps time so perfectly. The rogue planet seems to obey a law of symmetry unknown to us, as though the cosmos itself is performing an ancient ritual through motion and light. 4 listeners drifting towards sleep, the description turns meditative. Picture the wavelength curve like a heartbeat of the universe, soft rises, gentle falls, color turned into rhythm. It's peaceful, but underneath that peace hums a question that refuses to quiet down. Is this how the universe speaks? Through mathematics and light, through repetition that feels like memory? Or is it just our own longing, seeing meaning in the shimmer of data, the same way we once saw gods in thunder and faces in the moon? The scientists can only observe. The rest of us can only imagine. The pulse continues, painting its unseen message across the dark. And somewhere beyond Jupiter's vast storms, an ancient traveler keeps shining, its color bands changing like slow breathing in the void. The light that shouldn't exist continues to glow, fragile but steady, as if aware of the eyes fixed upon it. The narration slows to a whisper. Perhaps the universe is symmetrical, or perhaps it's signaling in a language we've only just begun to hear. The instruments keep recording. The wind passes over the domes. And in that moment between certainty and dream, the silence deepens. Yet hidden in that silence is something waiting to be understood. The night begins like all others in the deep deserts of Western Australia. Air still, sky open, the Milky Way curling overhead like a river of glass. Inside a silent control room, screens glow in pale blue, and a low hum fills the space, the sound of machines listening to the universe. No voices, no movement, only the patient rhythm of data arriving from the void. Then a flicker. A pulse. A single, almost imperceptible beat in the sea of cosmic noise. At first, the scientists at the Murchison Radio Observatory think it's interference. Static, satellite leakage, a forgotten calibration drift. It happens all the time, Earth's own chatter echoing back from nowhere. Yet this one is different. It carries a strange precision, repeating faintly in the same corner of the sky where the rogue planet was last tracked. 4 hours they let the receivers run. A soft signal, vanishing and returning. Then the pattern sharpens. Every 11 minutes and 47 seconds, a heartbeat from space. Across the ocean in South Africa's Karoo Desert, another array confirms it. The same pulse. Same rhythm. The world's quietest instruments, separated by half a planet, now hearing the same whisper in the dark. The data cross continents through fiber cables and encrypted channels. At NASA's Jet Propulsion Laboratory, a single phrase appears in a midnight message chain. Possible periodic emission, verify origin. The narration softens, allowing listeners to imagine the vastness behind that phrase. The hum of power lines, the gentle crackle of cosmic radiation washing across the antennas, the cool night air brushing against metal and stone. The pulse continues, unwavering. Scientists compare it to known pulsars, rotating neutron stars that blink like celestial clocks. But this signal doesn't fit. It's too slow for a pulsar, too consistent for a magnetar, too deliberate for random cosmic static. The team overlays the frequency on a spectrograph. No harmonics, no Doppler drift. Just clean, repeating precision as if the sender, whatever it is, knew exactly how to avoid distortion. They model magnetic field distortions, testing whether Jupiter's immense magnetosphere could have amplified background radio bursts. Simulations show nothing close to the 11-minute rhythm. The source seems detached from any planet, moon, or asteroid. Even solar wind analysis offers no clear culprit. The pulse emerges from the deep coordinates trailing the rogue traveler, an object that should have passed Jupiter's orbit weeks ago but still leaves a faint, gravitational echo. In the lab's dim red lighting, you can almost see the scientists' faces, eyes fixed on graphs, reflections shimmering like candlelight. There's awe but also restraint. In science, wonder must bow to proof. They catalog the data, cross-check timestamps, verify instrument calibration. One researcher whispers, could be a software feedback loop. Another murmurs, or a reply. Outside, night stretches endless and indifferent. A gentle wind stirs desert dust, and above it, the universe listens back. By morning, the discovery leaks into quiet corners of the internet. Amateur astronomers point their receivers toward the same region of space. Some record the pulse. Others claim to hear something layered beneath it. a subtle oscillation like two tones overlapping. The data forums buzz with theories. Is it plasma resonance? A rotating debris field? Or an artificial beacon? The tone of conversation is calm but charged, like the seconds before lightning. NASA issues a brief statement. No evidence of intelligent origin. Investigations ongoing. It's the kind of sentence written to quiet questions without answering them. But those listening closely, those who have traced the rogue's path, sense hesitation in the wording. No evidence doesn't mean no possibility. The narrator's voice lowers, almost a whisper. Imagine standing under a night sky that seems perfectly still, yet somewhere out there, something is counting time. Every 11 minutes and 47 seconds, a signal crosses the void, carrying no message we can read, no code we can translate, only presence. Theories bloom like constellations. Some suggest the pulse is caused by charged particles spiraling through magnetic turbulence left by the rogue planet's passage. Others propose an unseen companion body, perhaps a small metallic moon acting as a natural transmitter. But there's another, quieter theory whispered among the analysts, that the pulse didn't begin when the rogue appeared. It was always there. We just weren't listening in the right direction. In sleep-like cadence, the narration drifts through possibilities. If the signal is natural, it could redefine our understanding of magnetohydrodynamics, the study of how plasma behaves in vacuum. If it's artificial, it would be the first confirmed interstellar transmission of non-human origin. Both outcomes are extraordinary, both equally humbling. One technician describes it in poetic terms. It's like hearing a steady drumbeat in a forest you thought was empty. And perhaps that's what captures human imagination most. The sense that something is alive in the silence, not hostile, not even sentient perhaps, just aware. Night after night, the arrays continue to listen. Each repetition brings both comfort and unease. The pulse neither grows louder nor fades, it simply is. A constant in a universe defined by change. Some scientists start to record it during shifts, letting the rhythm fill the background as they work, a kind of cosmic metronome. In quiet moments, they confess it feels oddly personal, as though the signal knows it's being heard. The narrator's voice becomes softer, lulling. Every civilization dreams of contact, some message proving we're not alone. But what if the first message isn't meant to be read at all? What if it's just the sound of existence, steady, unbroken, echoing through eternity? In the calm that follows, the pulse continues. A reminder that silence is never truly silent. That somewhere, beyond Jupiter's storms and the drift of dust, a rhythm persists, ancient, patient, unexplainable. And as the data flows, the observers sit beneath their endless domes of stars, waiting not for an answer, but for understanding. The signal repeats, once, twice, forever, blending into the background hum of creation itself. The chapter closes in quiet reverence. The hum softens, the stars fade into a pale dawn, and for a moment the earth itself seems to breathe in rhythm with that distant pulse. The silence deepens, yet hidden in that silence is something waiting to be understood. It begins in near silence, an unbroken hum from deep space antennas listening to the void. In the quiet control rooms, a new designation appears across the data logs. Messenger Object J47. The name spreads softly at first, whispered among mission analysts, then repeated in encrypted channels between observatories. No one remembers who said it first. But once spoken, it carries weight, like naming a storm. The object moves with strange grace, crossing the heliocentric plane as if it understands gravity's rhythm. Its path bends not sharply but smoothly, threading invisible currents left behind by ancient comets. It is not fast but deliberate. Every kilometer feels chosen. Voyager's long-retired sensors, still faintly alive, register microperturbations, gentle tugs, the kind that only something massive and precise could cause. New Horizons, far beyond Pluto, echoes the same pattern, a near-synchronous drift, almost like a dance partner responding from across the solar dark. At NASA's archival facility, technicians replay the telemetry side by side. The graphs breathe in unison, tiny waves aligning across decades. Coincidence, say some. Gravitational resonance, say others. But to a few dreamers watching from the dim glow of mission monitors, it looks intentional, as though something is tracing humanity's exploration history backwards. They begin calling it the messenger. In the following days, internal chatter thickens. Someone compares the motion to a solar sail curve. Another suggests it's a captured rogue planet guided by unseen magnetic pressure. The skepticism remains polite, factual, but the tone feels unsettled, like scientists whispering in a cathedral. For every line of physics, there is a pause filled with awe. The narrator's voice softens. Imagine drifting through that space yourself, past the frozen plains of Pluto, through the soft blue arcs of Neptune's magnetic fields, and into a region where sunlight is no more than a pale memory. Out there, every object hums faintly with its own history. Perhaps J47 is not an invader but a listener, recording what light forgets. A spectrograph from the Mauna Kea Observatory shows odd reflections, faint and slow, repeating every 11 hours. Not a pulse, more like a breath. Astronomers argue its surface rotation. Others note the reflected frequency mirrors the intervals of Earth's early probe transmissions. When data patterns align that neatly, minds begin to wander. Could it be coincidence, or a response long delayed by distance? The tone remains calm, instructional. Facts are stated gently. The object has no clear orbit, its albedo too high for a dead rock, its trajectory leaning ever so slightly inward. But under that calm explanation lives a pulse of uncertainty. The term constructed probe appears in a late-night forum among astrophysicists, half in jest. Yet once typed, it lingers. From there, the story becomes human. An engineer in Pasadena remembers how, during Voyager's Golden Record project, there was a quiet discussion about, what if something sends it back? A half-forgotten memo from 1978 mentioned design symmetry as potential communicative principle. Now, 40 years later, someone overlays that geometry on the flight path of J47. The curves fit with unsettling precision. The narrator describes it softly, as though treading across dreams. The trajectory seems to bow at each region where human probes once passed. Pioneer, Voyager, Cassini's ghost orbit, even the New Horizons route beyond Pluto's frost. Each deflection subtle, like notes in a forgotten song. One could almost believe the universe itself is composing a reply. Skeptics counter quickly. They explain how gravitational tides from passing dwarf planets or dark matter pockets could create similar harmonics. They remind the public that space is full of coincidences, beautiful ones, yes, but coincidences all the same. Still, no one can fully explain the alignment of telemetry echoes, how data streams decades apart seem to fold into one long message. At the SETI Institute, a young researcher overlays the rogue's trajectory with Earth's outbound radio transmissions from the 1970s. Her model shows a faint intersection point, a bubble of cross signals somewhere near Jupiter's orbit. Inside that intersection, background noise drops by 0.3%, barely measurable. Yet her voice trembles when she says, "That shouldn't happen in vacuum." The story slows here. The narrator lets the words breathe. For centuries, humans have called themselves listeners. But what if we've also been speaking without knowing it? Our signals drifting like pollen across the cosmic wind, waiting for a reply that takes generations to arrive. There is no alarm in the tone, no fear, only wonder. The concept of a messenger reshapes itself from alien imagination into metaphor. Maybe J47 is not a device at all. Maybe it's the universe's reminder that everything we send, light, hope, memory, returns eventually. In calm reflection, the narration turns to the instruments themselves. Aging telescopes, cooling arrays, scientists leaning over flickering monitors. Their faces glow pale blue under the light of screens showing a single moving dot. One of them writes in her log, "Observation continues. Object maintains intentional drift." Another quietly adds, "Feels like it's watching." Outside, the night sky above Mauna Kea is clear, dotted with stars like frost on glass. The wind carries no sound, only the faint hum of tracking motors. Through that silence, the narrator speaks almost to the listener. Perhaps this isn't about who sent the message, but whether we're ready to understand it. The final moments settle like snowfall. J47's trajectory remains steady, neither accelerating nor fading. Voyager's ancient antenna, still whispering faintly from the darkness, catches a last signal bounce, one that mirrors Earth's own transmission in reverse order. A cosmic echo perfectly inverted. The data means little in equations, yet everything in feeling. It tells of distance crossed, of patience beyond human time, of something vast choosing to move gently rather than to strike. And so, the chapter closes not with fear but with quiet recognition. Whatever J47 may be, a planet, a probe, a coincidence, it has taught humanity to listen differently. To find meaning not in volume but in the spaces between signals. To imagine that observation itself may be a kind of compassion. The hum of the universe fades again to silence. Yet hidden in that silence is something waiting to be understood, a question too soft for instruments but clear enough for dreams. The universe at first glance feels orderly, stars tracing paths, planets following their invisible orbits, everything locked in a quiet rhythm. But beneath that calm lies gravity's wild truth. Even harmony can shatter. When a binary star collapses, its companion's pull can twist and tear worlds away, sending them drifting into eternal night. The narrator speaks softly, explaining how astrophysicists simulate these cosmic divorces on glowing monitors, each line of code recreating the heartbreak of separation. In one model, a planet the size of Neptune circles a dying sun. Then, with a silent wrench, a gravitational flick sends it spinning into blackness. The researchers call it ejection, but in quieter terms it's exile. The world is not destroyed, it simply loses home. The narrator compares it to a dancer whose partner vanished mid-step, left spinning in a hall with no music. Gravity in its relentless balance does not choose cruelty, it merely obeys mathematics. Stars are born in clusters, and sometimes their closeness breeds chaos. A companion star collapses, its mass compressed into a white dwarf or neutron core. The sudden shift in gravity breaks the orbiting geometry, hurling one planet after another into the deep interstellar sea. In those simulations, the planets keep moving forever, cold and unlit, carrying traces of the suns that cast them out. The listener can almost picture them, wandering orbs cloaked in frost, gliding through the whispering dark. No sunrise, no orbit. Only the gentle hiss of cosmic radiation against frozen rock. Telescopes can catch their passing only by accident. A flicker in starlight, a faint lensing of a background galaxy. Astrophysicists call them rogue planets. The narrator's tone turns hushed, as if describing lost travelers moving under a pale veil of starlight. In the labs, scientists speak in numbers, mass ratios, velocities, escape thresholds. But behind those numbers is awe. Gravity, they say, gives and takes with equal grace. Every orbit is a promise, every escape, a reminder that even laws of physics allow abandonment. Invisible strings snapping in silence, the narrator murmurs, returning to the image from the memo's notes. One snap and the pattern changes forever. The narrator invites the listener to imagine this. A rogue planet passing near Jupiter's orbit, its trajectory not malicious but inevitable, a relic of another sky. It carries the gravitational fingerprint of a dead star, a memory of warmth long faded. If planets could dream, this one would remember the golden light that once bathed its clouds before darkness claimed it. As the music softens, the narrator describes the subtle beauty of these cosmic wanderers. Some might harbor frozen oceans beneath ice shells. Some might still glow faintly from radioactive decay deep in their cores, a heartbeat beneath layers of frozen dust. And if, by chance, one drifts close enough to a young star, gravity might capture it again, like a lost ship finding harbor after millennia adrift. This is gravity's rebuttal to fear. The rogue planet, the scientists argue, is not a threat but a story, a natural outcome of the universe's restless dance. Gravity isn't just destruction, it's motion, balance, renewal. When a system collapses, something else begins. Somewhere, another star gathers dust and gas, pulling the next world into being. The cosmos, in its vast cycles, forgets nothing. The narrator lowers their voice. Perhaps NASA's memo wasn't about danger, they say. Perhaps it was an acknowledgement of inevitability, of how creation and loss share the same orbit. The tone shifts toward comfort. What we call chaos might simply be a wider form of order, too large for human minds to see all at once. Imagine looking up tonight, the narrator suggests, at Jupiter's soft glow, unaware of the invisible forces shaping its path. Around it, unseen, the gravitational tides ripple outward like breath. In those tides might be the faintest signature of a traveler long exiled, crossing our solar system not to disrupt, but to remind. Gravity has no malice. It pulls, it releases, it reclaims. It is both destroyer and artist, sculpting the silence between stars. And in that silence, every drifting planet is proof that even after separation, motion continues. The narration fades, leaving only a soft hum, like wind over frozen plains. Somewhere in that hush, a question lingers. If gravity can let go so easily, what other bonds might the universe someday break? The night is still inside NASA's data analysis wing, a place that rarely knows the difference between midnight and morning. Rows of silent monitors hum with a faint blue glow. Screensavers drift across the dark like slow-moving stars. Somewhere beyond the glass, the desert wind brushes the building's metal skin, whispering through the vents as though even it has come to listen. A technician in a gray sweater walks down the corridor, holding a folder marked with a faint red stripe. Nothing unusual except for the timestamp, 3:47 a.m. The folder contains a reprint of a memo, unclassified only for internal circulation. At first glance, it looks routine, just another log of optical readings. But a few words draw the eye like fireflies in the dark. Anomalous albedo. Possible plasma sheath. The terms are technical, yet they feel heavier than they should. Albedo is the measure of reflectivity, the way a surface returns light. Planets and moons wear their albedo like fingerprints. Ice gleams, rock absorbs, gas clouds scatter. But anomalous means something broke that fingerprint, something reflected light that should not exist in the first place. The memo, printed on bright fluorescent paper, glows faintly under the overhead lights. Dust motes drift across it, tiny galaxies caught in their own orbits. A reader flips through the pages slowly, tracing lines of data with the edge of a pencil. The numbers pulse softly like a hidden rhythm, coordinates, velocities, temperature gradients, yet the reflection ratios rise and fall like a heartbeat. It is beautiful, almost alive, and that is what makes it unsettling. At the far end of the lab, a projection screen glows with an enlarged image. It shows a faint blur near Jupiter's orbit, a sphere wrapped in a thin halo, half shadow, half shimmer. The scientists call it sheath interference. To anyone else it might look like fog captured by starlight. But inside that fog, some pattern seems too precise, too intentional. One analyst adjusts her glasses and whispers, "That's not lens noise." Another replies, "Then what is it?" No one answers. The silence of the room feels like a pause in the universe itself. The narrator's tone softens as if wrapping the listener in the same silence. Imagine standing there, surrounded by light that behaves like thought, something not just reflecting but deciding how to reflect. The data isn't chaotic, it's selective. Certain wavelengths vanish, others amplify. It's as though the object knows when it's being watched. In the margin of the memo, someone has handwritten, "Do not release until verification. Level 7 optics only." The signature beneath is half erased, the ink smeared by a thumb. Another note reads, "If sheath confirmed, origin unknown." Months after the first leak, this second document spreads quietly through internal channels. Analysts trade cautious glances, unsure if they're reviewing legitimate science or a test of their loyalty. For every theory they form, a counter-argument shadows it. Plasma sheaths can appear around high-velocity objects. They can also form around artificial ones. Re-entry probes, ion engines, magnetic sails, all have shown similar readings. But this object, drifting beyond Jupiter's magnetosphere, shouldn't be carrying anything at all. The narration drifts to a soft, sleep-like rhythm. In the cradle of darkness, Jupiter turns endlessly, its storms swirling like slow oceans of color. Lightning flashes illuminate its clouds for only a second, like thoughts in the mind of a sleeping god. And somewhere beyond that, this rogue traveler glides through emptiness, wrapped in light it does not need, guarded by a silence it does not break. Within the lab, debates grow quieter as the night deepens. One scientist leans back in his chair, rubbing his eyes. "Maybe it's just calibration error," he says, but no one moves to agree. The projector hums softly, showing another frame. The halo shifts shape ever so slightly, as though caught mid-motion. The memo references an earlier observation, cross-linked to an infrared pass 2 weeks prior. That data suggests the sheath temperature fluctuates between -173 degrees Celsius and +25 degrees Celsius within minutes. A range no known atmospheric layer could sustain without energy input. In calm, deliberate narration, this is explained. For plasma to hold form, there must be a field to contain it. Magnetic, artificial, or something unknown. The scientists gather around the display as if standing at a campfire in the dark. Their faces glow with reflected light. The oldest among them speaks quietly, "You ever notice how the more data we get, the less we understand?" It earns a tired laugh, the kind born of or rather than humor. In the background, a ventilation fan hums like a low drone of the cosmos. A printer clicks once, and the final page of the memo slides out. Last line highlighted in faint red. Visual reclassification recommended. Treat as unknown transient object until confirmed otherwise. The word transient feels safe, bureaucratic, clinical. But to those who've stared too long into Jupiter's halo, it sounds like denial wrapped in syntax. The chapter breathes slower now. The narrator's voice lowers. The memo may have been an internal draft or perhaps deliberate misdirection, a decoy to redirect inquiry away from deeper truths. History has seen such tactics before. The Pentagon Papers. The delayed release of Hubble's flawed mirror results. Even the simple act of renaming data can hide it in plain sight. Outside the laboratory, dawn approaches. The desert horizon begins to glow pale blue, and the first birds stir in the cooling air. Inside, however, time feels paused, no clocks tick, no keyboards clatter. The scientists simply stare at the glowing projection, their eyes reflecting the same faint shimmer that dances beyond Jupiter. In this calm twilight between certainty and doubt, one question lingers. When truth hides behind classification, is it to protect minds from fear, or to protect those who already know? The narrator's tone softens further, almost a whisper now. Sometimes the greatest mysteries are not written in encrypted codes or telescope data, but in the hesitation before a scientist speaks. In that breath, humanity reveals both its wonder and its fear. The image on the screen flickers once more. The halo seems to pulse, once, twice, before vanishing into static. Someone notes the timestamp, but no one writes a conclusion. Outside, sunlight spills across the desert floor, yet inside the air remains heavy with the scent of ozone and uncertainty. The fluorescent pages lie scattered across the desk, glowing faintly, as though they still carry the light of what they tried to describe. And as the day begins for everyone else, the silence in that room feels endless. A silence filled not with absence but with waiting. Somewhere beyond Jupiter's wide embrace, something continues its quiet drift through the cradle of silence. And in that drift, an unseen story keeps unfolding, just beyond the reach of certainty. The glow fades but not the question. The data sleeps but the mystery does not. The night air around the mountain observatories carries a faint chill, a whisper that slides through the corridors between glass domes and telescope towers. Inside the cafes that cling to these slopes, a few astronomers linger past midnight, their screens glowing pale blue in the darkness. Steam rises from their coffee cups like nebular mist, curling into the hum of whispered conversation. They speak softly, careful not to be overheard. To anyone passing by, it sounds like ordinary scientific banter, until a certain word drifts through the air: the rogue. They never say its full designation. Each one has a different nickname for it. Some call it the Harbinger, others the Mirror of Jupiter. On encrypted chat servers, messages slip back and forth under aliases that mean nothing but sound poetic: night lens, aurora drift, silent orbit. In these private digital corners, the tone is cautious, like priests handling an unnamed relic. Every conversation begins the same way: did you see the new curve? Or, the reflection pattern changed again. There's laughter too, but it's thin, tired. You can almost hear the fatigue in their voices, the kind that comes from weeks of staring at data that refuses to fit any model. They joke to ease the tension, trading theories that sound more like bedtime stories than astrophysics. One scientist insists it's a rogue planet captured temporarily in Jupiter's gravity. Another claims it's an old interstellar traveler shedding its crust like a dying ember. A few whisper what no one dares to record aloud: that maybe it isn't just passing through. In dim corners, their laptops flicker with graphs and faint, jagged lines. These are the light curves, the rhythmic dance of brightness and shadow measured from telescope images. Normally, such curves tell predictable stories: rotation, reflection, orbital spin. But these are different. They pulse irregularly, almost as if responding to observation itself. A scientist leans in, squinting at her monitor. "It flared when we looked," she murmurs. Someone else replies, "Then stop looking." The group falls quiet. The cafe's clock ticks softly above them. Outside, the sky is an ocean of velvet, stars scattered like fine dust. A wind moves through the high-altitude pines, carrying the faint scent of ozone and frost. In the silence between footsteps and keystrokes, there's a feeling that something vast is listening back. One researcher types a line into the encrypted forum: "We're not observing it anymore, it's observing us." The message vanishes seconds later, deleted by its author. Rumors ripple through the digital channels. A team in Chile claims their infrared array picked up a heat signature inconsistent with a planetary body. Another in Arizona reports a dim triangular reflection appearing once, only once, during a calibration frame. The screenshots leak quietly, forwarded through private accounts, stripped of metadata, passed from one cautious believer to another. No official channels mention it. NASA's daily briefings remain clean, clinical, unbothered. But inside these small circles, anxiety and awe mix like gravity and light. They are not conspiracy theorists. They are dreamers trained to measure the cosmos in decimals and degrees. Yet something about this anomaly cracks that shield of logic. One scientist, usually stoic, writes to her colleague at 3 a.m. "When I zoom into the curve, I feel like it's breathing." Another replies, "I know. Don't tell anyone you said that." The narrator's voice slows, almost whispering over a background of soft electronic hum. Servers cooling, night insects outside, distant thunder beyond the mountains. There's a fragile beauty in this secrecy, a human tenderness hidden beneath professional restraint. These are people caught between wonder and fear, between what they know and what they feel. Their faces glow. In the monitor light, eyes tracing data points like constellations on glass. The cosmic dread has softened into something more intimate. A quiet recognition that discovery always costs a piece of certainty. Hours stretch into dawn. The first light creeps across the horizon, painting silver edges on telescope domes. The cafe empties, chairs scraping softly against the floor. Only a few linger, still murmuring about trajectory estimates and spectrograph lines. One man pulls up a still image, just a gray blur against starfield noise. But near the edge there's something else. A faint outline, almost invisible unless you know where to look. 3 points of reflected light, forming a perfect triangle. He zooms in, heart slowing with each click. The pixels hold steady. No distortion, no artifacting. Just geometry in the void. He leans back, exhales, and saves the frame under a file name no one will understand. Then he closes his laptop. Outside, the morning wind stirs the trees. The observatory domes turn their faces toward the brightening sky, sensors cooling in the soft light. The encrypted chats fall silent for a few hours, like a heartbeat resting between pulses. Somewhere, in the deep channels of data storage, that triangular frame waits, unremarkable, unread, unconfirmed. And in the quiet that follows, it feels as though the cosmos itself has drawn a breath. Not to speak, not yet. Just to listen. The world carries on beneath the waking sun, unaware that far above it, a faint reflection, sharp-edged, precise, deliberate, drifts through the darkness, holding its secret shape. And in that drifting quiet, one could almost sense that another secret was about to reveal itself. The frame appeared first as a whisper in the data, 3 faint points of light forming a near-perfect triangle against the endless black. At first glance, it seemed like nothing more than a trick of starlight, the sort of alignment that happens 1,000 times a night when telescopes stare long enough into infinity. But then one scientist paused the feed. Another zoomed in. The edges sharpened, the angles held, and a hush settled over the small observation room. In the gentle hum of computers, the image floated on the screen like a dream. 3 symmetrical glints, equidistant, unwavering. They were positioned just at the edge of the rogue planet's silhouette, as if tracing something invisible, something vast. Around them, space was quiet, but the geometry spoke its own quiet language. Triangles, after all, are rarely accidental in nature. Spectrographs flickered. Analysts began checking for optical ghosts, sensor noise, cosmic rays. Every possibility was tested, and yet the pattern persisted. The object seemed to catch and reflect the dim light of distant stars, not chaotically but with deliberate rhythm. It was too clean for coincidence, too calm for chaos. The narrator's tone softens, inviting the listener to imagine it. A dark sphere adrift beyond Jupiter, rimmed by 3 glimmers that pulse like beacons beneath a velvet sky. The faint hum of instruments blends with the low static of cosmic background noise. A soft glow, a drifting shadow, and the question begins to breathe. Is this geometry simply an illusion of light, or a structure? In the days that followed, researchers from multiple observatories examined the readings. Some claimed atmospheric diffraction. Others blamed the telescope's angle relative to Jupiter's magnetosphere. Yet, in private forums, a few astronomers used different words. They called it the frame. A boundary. A doorway. Something ancient and cold, waiting in the void. Historical notes surfaced, linking the formation to earlier anomalies, glimpses of impossible symmetry in deep-field images, forgotten or dismissed. The Kepler array once recorded a similar triangular flicker in the Cygnus sector, brushed aside as data compression error. A researcher in Tokyo remembered 1999, when IRIS captured a 3-point echo near Saturn's orbit. Each event had vanished from public logs, archived under uncorrelated visual artifacts. Still, patterns endure where memory fades. And the triangle, the simplest form of stability, returned again. Commentators outside NASA began referencing Dyson spheres and megastructure hypotheses, theories once confined to the edges of astrophysics. Could the rogue object carry fragments of an engineered frame? Something to harvest light, or to store energy from a dying star? The narration remains calm, offering possibilities like drifting clouds. No fear, only wonder. Each idea hangs weightless for a moment before fading into the soft hum of space. One voice, measured and skeptical, breaks through, Sometimes, a senior researcher says, the human brain sketches meaning upon noise. The line lingers in the stillness like a truth we half believe. The narrator's tone lowers as if inviting the listener to breathe slower, to feel the rhythm of data and doubt. Our eyes, wired for order, often see patterns where none exist. But sometimes, rarely, the universe obliges that pattern and answers back. To understand the light, scientists ran angle correlations. They found that the three reflections aligned with the rogue's estimated spin axis, an angle of 42 degrees relative to Jupiter's orbital plane. If random, the odds were microscopic. If real, the implication was extraordinary. The rogue might not be a simple rock. It could be a world encased in geometric symmetry, or wrapped in mirrors reflecting stars in measured sequence. Weeks passed. New images arrived, grainy, blurred by distance. The triangle shimmered faintly, like a memory at the edge of vision. Some nights it vanished altogether. Other nights, it returned stronger, brighter, more defined. Astronomers debated fatigue, confirmation bias, even subconscious desire. The human need for meaning is gravity of its own kind. It pulls, distorts, bends light and logic alike. Outside the labs, the public heard whispers. Blogs speculated about the Trinity lights. Forums spoke of coded alignments, secret signals and hidden watchers. But inside the scientific community, the tone remained gentle, careful. They spoke of diffraction gradients and photometric precision. Even skepticism here sounded like poetry. Still, there were moments, quiet, personal ones, when even the most logical observer felt a twinge of something deeper. A junior astrophysicist, standing alone beneath the observatory dome, whispered, "It looks built. Not as claim but as confession." The stars above shimmered through the thin atmosphere, and for a second, geometry became faith. The narrator slows. If geometry repeats across galaxies, the voice muses softly, could intelligence repeat too? The listener can almost see it. The same shapes echoed in the crystalline snowflake, in the orbital paths of moons, in the delicate spiral of DNA. The cosmos speaks in ratios and symmetry. Maybe that's the common language between chaos and mind. Simulations rendered the object in digital silence, a dark mass framed by 3 points of impossible precision. As the model rotated, it cast reflections in a way that suggested curvature, not flatness. It wasn't a triangle at all, but perhaps the corner of something greater, one visible facet of a larger design hidden in shadow. The thought lingered in late-night conferences. If it is structural, someone whispered, what's the purpose of hiding geometry in darkness? No one answered. Some mysteries resist the light. Far beyond, the rogue drifted in its slow dance with Jupiter's pull, like an ancient traveler carried by unseen tides. The triangular reflection pulsed once more, faint as breath, then dissolved into the starfield. Observers noted the timing. It occurred precisely when the gas giant's magnetic field flared. Coincidence or reply? In the cradle of silence that followed, humanity's instruments fell quiet again. For all our data, for all our precision, the truth remained a sketch upon noise. Yet somewhere between reason and wonder, meaning took shape. A geometry in the void, hinting that the universe in its vast emptiness still draws deliberate lines. The hum of distant servers fades. The stars drift across an invisible grid. And in the long, slow rhythm of the cosmos, a faint thought glimmers like starlight through mist. Perhaps intelligence is not unique to us, it is geometry remembering itself. The silence deepens, and within that silence, something still waits to be understood. The night sky hums, though few can hear it. In deep space recordings, buried beneath the static of solar wind and cosmic rays, a rhythm emerges, steady, precise, and impossibly familiar. The 11-minute pulse, once dismissed as background interference, now reveals patterns that defy randomness. Within the laboratories of NASA's Goddard Space Flight Center, a quiet team of astrophysicists works under dim lights, listening. What they find is not chaos, but composition. Ratios that mirror the spacing of planets, the subtle mathematics of motion, the hidden song of the cosmos. Every wavelength is translated into sound. Data becomes melody, an audible map of gravity and distance. The rogue planet, once a silent shadow crossing between stars, now hums with measurable frequency. As computers convert the electromagnetic signatures into tone, the room fills with a low, trembling harmony, as if a distant choir were breathing across the void. One scientist writes in his log, "It's as if Jupiter is being answered." Through simulation they discover a pattern. The pulse aligns not randomly but sequentially with the orbital resonances of our solar system. Like a conductor tracing invisible circles, the rogue's frequency swells near Jupiter's cycle, softens near Saturn's, and pauses, perfectly timed as if aware of the sun's heartbeat itself. Ratios emerge: 2 to 3, 3 to 5, 5 to 8. Numbers that echo through music, architecture, and planetary motion. The mathematics of harmony, long thought a human invention, reveals itself written in starlight. The narrator's tone softens, the imagery turns luminous. Imagine sitting in that dim control room, surrounded by screens that glow pale blue. Outside, the night stretches infinite and cold, yet within the silence there is warmth, a fragile sense of recognition. You listen as the sound rises, not mechanical, not human, but something in between. A tone that feels both eternal and personal, as if the universe itself is whispering through a wall of distance. To astrophysicists, harmonics are a bridge between order and chaos. They measure vibration, not intention. And yet, this pattern feels deliberate. One researcher compares it to the harmonic ladder of the hydrogen atom, those faint intervals that define all known matter. Another calls it a mathematical mirror, a reflection of cosmic symmetry. The team debates for hours whether such structure could emerge by accident. The probabilities shrink to near zero. Still, the official report avoids words like message or communication. Instead, it labels the finding a resonant anomaly. Outside the observatory, the night wind moves through the desert, a soft, endless hush. Overhead, the Milky Way drapes across the sky like a river of powdered light. Somewhere within it, an object drifts, older than memory, older perhaps than the sun. Its frequency, stretched by distance, continues to hum through deep space arrays. The tone is constant, but modulated by something unseen, like a thought changing mid-sentence. They test for pulsar mimicry. They rule out reflections from Jupiter's magnetosphere. They account for solar interference. Yet the sound remains perfectly steady. When sped up, it sounds almost like a heartbeat. When slowed down, it resembles the faint strum of a cello bow against endless strings. A cosmic chord sustained over millennia, waiting for ears capable of hearing. Late one night, an engineer overlays the harmonic data with the orbital map of the solar system. What appears is astonishing, a fractal rhythm repeating across scales. The gaps between planets echo the intervals in the pulse. Each note corresponds to gravitational balance points, Lagrange harmonics where dust, ice, and time converge. The rogue object's path seems to trace these invisible nodes, as though following a melody written in the architecture of gravity itself. Could it be coincidence? Perhaps. The cosmos breeds patterns endlessly, and the human mind is a net eager to catch them. But perhaps not. Perhaps harmony is not something we impose upon the universe, but something the universe uses to speak in a language we barely recognize. The narrator breathes softly. Imagine that every orbit is a note, every collision a chord, every silence a rest. Then in the hush that follows, the rogue's pulse plays once more, distant, unwavering, almost kind. If the universe composes, this may be one of its earliest symphonies. And if we are listeners, then perhaps this discovery is less about finding music in space and more about finding ourselves tuned to it. As the final waveform fades on the screen, one scientist closes her eyes and whispers, "It's not random, it's remembering." The sound lingers, a shimmer of mathematics, a whisper of connection, until it slips beneath the threshold of hearing. In that fading vibration lies something vast and patient, a sense that the cosmos is not empty, but aware in ways we cannot yet define. And in the drifting quiet that follows, one could almost sense that another secret is waiting, hidden within the silence between the notes. The silence of space has its own kind of gravity, one that pulls not only planets but attention. As the rogue object slips toward Jupiter's vast magnetic field, the world holds its breath. From mountaintop observatories in Chile to small backyard telescopes glowing under suburban skies, eyes and instruments lock onto the gas giant. Every screen displays the same thing, a faint point of light approaching the planet that has always been our solar system's storming sentinel. Jupiter, a world of thunder and hydrogen, spins in tranquil defiance of time. Its clouds roll endlessly, each swirl larger than continents. Tonight they shimmer differently. A strange luminescence, blue and cold, ripples across its surface like a heartbeat of lightning seen through deep water. The planet's auroras, already the grandest in the solar system, bloom brighter, stretching farther than ever before recorded. Cameras adjust exposure, filters burn out. The phenomenon is breathtaking, impossible to fully describe. To the scientists watching in quiet awe, it's as though the planet is responding to something unseen. NASA's live monitoring feed from the Juno spacecraft begins to hum with bursts of data. The object, classified under temporary code J47, is now well within Jupiter's magnetosphere. At this distance, it should behave predictably, pulled into the planet's gravitational curve or flung out toward the void. But the telemetry disagrees. Its trajectory doesn't quite match any of the models. It slips through the currents of charged plasma like a fish gliding through unseen water. The narration slows, like a heartbeat resting between beats. Engineers at Mission Control speak in low tones. The object is still visible, small, reflective, stable. Then, without any announcement, it slides behind Jupiter's massive disk. A simple eclipse, they assume, a matter of orbital perspective. Yet as the minutes stretch to hours, something unnerving happens. It doesn't reappear. 20 minutes pass. Then 60. Then 4 hours. No signal bounce, no reflected light, not even static. The world's greatest array of instruments, all tuned to the same coordinates, detect nothing. It's as though the object has evaporated into Jupiter's shadow. The voice of the narrator softens, almost whispering. In space, silence is rarely still. It is the sound of waiting, of listening. For 72 hours, that silence holds. Scientists alternate shifts, sipping coffee gone cold, staring at screens filled with noise and static. The Deep Space Network, so sensitive it can catch a whisper from a billion miles away, registers a temporary blind zone. The phrase sounds clinical, but beneath it is unease. Jupiter's immense magnetic field can distort signals, yes, but never erase them completely. Not like this. Somewhere in the stillness, imagination fills the void. Was it destroyed, swallowed by gravity, burned in radiation? Or did it simply choose to hide? The narrator lingers on the idea, not of disappearance, but transformation. Every time humanity looks deeper into the cosmos, something stares quietly back. The telescopes become mirrors as much as windows. On the third day, as dawn spills across the deserts of Arizona and night deepens over Tokyo, a flicker appears. A faint echo, a single reflected beam, strikes one of the receivers at the Goldstone complex. It's weak, nearly indistinguishable from cosmic background noise. But within the pattern, there's motion. The signal isn't coming from behind Jupiter anymore. It's coming from the opposite direction. Analysts scramble, whispering confirmations across networks. Triangulation begins. The beam is clean, narrow, consistent. No sign of random scatter. It isn't drifting outward into the deep as a typical ejected fragment might. Instead, its path curves inward, toward the sun. The realization arrives slowly, like dawn rising over frost. Whatever the object was, whatever it did behind Jupiter's immense curtain, it is now changing direction. No natural body should behave like this. Not without propulsion, not without intent. Yet there it is, the faintest trace of reflected light arcing sunward, as if drawn by something deeper than gravity. The narration invites the listener to picture it. A lone, ancient traveler caught in the pull of our solar heart. Around it, the gas giant glows like an enormous guardian, its magnetic field shimmering in ripples of sapphire and violet. Beyond, the black canvas of space stretches into infinite stillness, pricked only by stars that seem to blink slower than before. In laboratories, scientists run simulations, some whispering about slingshot trajectories, others about unknown magnetic properties. The data doesn't satisfy. It humbles. Sometimes, in the face of cosmic behavior that defies explanation, the only rational act is silence. Outside observatories, the night remains perfectly calm. Crickets hum. The air feels ancient. Someone somewhere looks through a telescope and sees Jupiter rising, huge, radiant, but distant enough to seem harmless. If they looked long enough, they might notice a glimmer near the planet's limb. Not a star, not a moon, but a reflection caught between movement and meaning. The narration slows further. In the end, space rarely answers our questions. It only returns them, folded into light. As the beam grows faint and drifts toward the inner system, the scientists who first reported the anomaly simply note its path. They do not name it, not yet. There's a quiet agreement. Some mysteries must be watched before they are understood. And so, data streams resume. Instruments realign. Jupiter continues its rotation, its storms unbroken. The auroras fade back to their familiar emerald shimmer. To the public, everything appears normal again. To those who have seen the raw telemetry, the night feels different, like standing at the edge of a whisper that might speak again. Somewhere beyond numbers and sensors, an object moves unseen, tracing its curved path inward. Maybe it seeks the warmth of the sun. Maybe it follows momentum born in another galaxy. Or maybe, in the soft glow of its silence, it carries something we were never meant to interpret, only to feel. The chapter closes in hush. Jupiter's shadow lingers like a curtain slowly falling, and behind it, something continues its journey. The silence deepens, yet hidden in that silence is something waiting to be understood. It was supposed to be gone by now. Every orbital projection, every simulation, every equation had drawn the same line, outward, away from the sun, vanishing into the quiet between stars. Yet as the deep space telescopes tracked the rogue planet's fading signal, something unexpected began to happen. Its trajectory curved. Slowly, almost shyly, the object turned back toward the light. In the dark hours before dawn, observatories across the world confirmed it. The rogue was returning. Its new path threaded back into the inner solar system, slipping once more between the orbits of Mars and Jupiter, dragging behind it a shimmering veil of ionized dust that caught sunlight like powdered glass. Through each telescope lens, that dust looked soft and luminous, silver filaments unfurling through the black. A trail that refused to disappear. The scientists called it a reversal event, but no one could explain the cause. Rogue planets do not turn around. They do not listen to gravity as if it were a whisper. And yet this one did. At the European Southern Observatory, spectrographs began to capture something even stranger. Within the dust were spectral lines that matched no known element. The peaks and valleys on the screen looked familiar at first glance, like hydrogen, oxygen, or carbon. But in each, a subtle offset appeared as if reality itself had been tuned half a note higher. An element that pretends to be known, one researcher murmured, staring at the data long after the monitors dimmed to sleep mode. NASA's analysts compared the readings to archives of comet tails, asteroid emissions, even plasma plumes from ion thrusters. Nothing fit. The wavelengths drifted slightly over time, pulsing in cycles that resembled biological rhythms more than chemical decay. It was as if the rogue carried a living trail, matter that breathed faintly in the sunlight. For days the news channels avoided it. The story lingered only in academic emails and encrypted research exchanges. The tone was calm but cautious, as if everyone was waiting for someone else to define what they were seeing. By the time the public caught up, the object had already crossed the asteroid belt, tracing a ghostly path between ancient stones left from the solar system's birth. Out there, amid the silent rubble of creation, its glow seemed almost reverent. One probe, the aging dawn relay, caught a brief visual. A soft silhouette against starlight, its surface faintly iridescent, like frozen lightning beneath a veil of mist. Then, without warning, its signal vanished, just static, fading into a cradle of silence. Speculation bloomed quietly in the spaces between science. Some proposed solar sail dynamics, thin sheets of reflective material catching the faint pressure of sunlight, steering the object like a drifting ship tacking into the wind. Others imagined self-propelled jets of outgassing vapor, or magnetically charged arcs guiding its motion through invisible fields. Each theory held for a moment, like a candle's flame in still air, before collapsing under its own uncertainty. Every answer birthed another question. Meanwhile, Jupiter loomed behind, watching like a silent witness. The rogue's dust trail shimmered against the planet's reflected glow, twisting like a ribbon caught in cosmic wind. Instruments picked up faint electromagnetic interference, a low hum that pulsed across radio bands. Some dismissed it as solar wind noise. Others noticed the pattern matched the object's previous radio rhythm, the same 11 minutes and 47 seconds. A heartbeat in the dark, repeating as it passed the orbit of Mars. On Earth, night sky watchers began to notice a new light near the ecliptic plane, a slow-moving point that seemed to pulse when stared at for too long. In remote places where streetlights surrendered to starlight, a few said they could see the faint dust stream with their naked eyes, a soft smear like the Milky Way bending closer. The narrator's voice softens, blending science with wonder. Imagine stepping outside tonight, feeling the cool air settle against your skin, and looking up to see a thread of light drifting where none should be. It moves so slowly you're unsure whether it's moving at all. But deep down you sense it isn't gone, it's circling back as if remembering us. Back in Pasadena, a young astrophysicist named Arjun recalculates orbital dynamics with trembling hands. His model predicts something both beautiful and terrifying. The rogue is not on a collision course nor escaping, it's in survey mode, tracing a looping arc that brings it closer to the sun, then outward again in perfect resonance with Earth's orbit. The spiral. A pattern that feels deliberate. He doesn't say this out loud. Instead, he writes in his private log, "If this is farewell, it's the kind that waits to be noticed." Days later, new spectrographs reveal microbursts of light flickering along the dust plume, tiny flashes synchronized across hundreds of kilometers, almost like coordinated beacons. Energy reflections, the official report reads. But those who look longer see something else. Order within chaos, symmetry within noise. It's as though the dust itself is carrying instructions. And still, the rogue planet continues its quiet drift through the solar sea, neither threatening nor fleeing, its luminous trail wrapping the darkness in something eerily gentle. Observatories keep their gaze steady, tracking the faint shimmer as it slips past Mars' orbit. Scientists describe it clinically as anomalous but stable. Poets, however, find other words, an ancient traveler tracing its memories in sunlight. The narration slows, easing into the rhythm of breathing, like a lullaby disguised as science. The soundscape hums softly, the faint static of space, the whisper of solar wind brushing past metallic sensors, the distant heartbeat of a world no one understands. The rogue glides on, silent and patient, as if it knows we're watching. It does not threaten, does not speak, does not vanish. It simply drifts, like a messenger that has seen what it came to see. And as daylight edges across Earth's horizon, turning the observatory domes from silver to gold, one question lingers in the soft static of morning. Was this its farewell, or the beginning of its survey of us? The telescopes keep listening. The light keeps moving. And somewhere between Mars and the Sun, the traveler sails on, leaving behind only a trail of silence that glows faintly, like memory refusing to fade. It begins with silence. Not the empty kind, but the kind that follows revelation. The hush after the storm, when the mind no longer races and only listens. Across the planet, the noise of news has softened into whispers. Screens glow dimly in dark rooms, webcams flicker to life, and somewhere between the hum of computers and the faint breath of night air, the world begins to speak as one. Philosophers, poets, and physicists gather not in grand halls, but in live streams. Their faces are framed by the blue light of laptops, eyes reflecting constellations of pixels. 1,000 windows connect. Basements, laboratories, city rooftops, and bedrooms filled with the quiet hum of curiosity. They are watchers. Ordinary people drawn by the same invisible thread, seeking to understand the rogue planet now looping through the solar system. The tone is gentle. One astrophysicist, her voice trembling slightly, quotes Carl Sagan, "We are a way for the cosmos to know itself." Another smiles softly, replying that maybe this time, the cosmos decided to look back. Their conversation feels like music, slow, thoughtful, interspersed with long silences that say more than any word. A poet reads a verse about the loneliness of worlds, how gravity ties them together even across light years, just as hope ties us through time. In the background, calm music drifts like dust through sunlight. Piano notes echo against faint radio static, the same frequency once used to listen for signals beyond Earth. The rogue planet becomes less a threat, more a mirror. It reflects not light, but emotion, the awe of discovery, the ache of isolation, the fragile bond between knowledge and mystery. The watchers from every corner of Earth begin to feel something shared, a collective stillness as if standing together. Beneath one infinite dome. The narrator describes the scene not as an event, but as a feeling suspended in orbit. Imagine this moment. A room lit only by starlight from a monitor, a mug cooling beside you, your own reflection faint in the glass. Outside, the wind moves softly against the window pane. Inside, someone whispers, "Do you ever feel like it's looking back?" And you realize they mean it, not with fear but with wonder. Physicists talk about mirror matter, hypothetical worlds made of particles that pass through ours unseen. The poet compares that to the human condition, how we drift beside one another, mostly invisible, crossing paths only when light hits at the perfect angle. The philosopher nods slowly, saying the rogue planet is just another mirror, forcing humanity to confront its reflection. Maybe it was never about aliens or warnings. Maybe it's about seeing ourselves in the dark. Through telescopes, data streams continue. Spectrographs trace the rogue's faint tail, ionized dust shimmering like a watercolor brushstroke across the black. Its trajectory, now stable, promises no collision, no danger. And yet the fascination grows stronger. Scientists who once measured only speed and angle now measure meaning. What does it say about a civilization that gathers not in fear, but in curiosity? A soft voice recites lines from Maya Angelou, "We are more alike, my friends, than we are unalike." The words settle like gentle dust over the broadcast, carried by a million speakers into bedrooms and earbuds. In that quiet resonance, science and poetry become the same language, both searching, both listening, both unfinished. The rogue planet, unseen by the naked eye, continues its slow dance beyond Jupiter. Somewhere deep in its wake, instruments record faint distortions, subtle changes in background radiation, almost imperceptible. Most dismiss them as calibration errors, but one data analyst hesitates. The pattern doesn't match noise. It repeats faintly beneath the static. No one mentions it yet. The watchers are too lost in the beauty of their own connection. Comments flood the chat windows. Lines of poetry, personal confessions, the locations of listeners. Tokyo at sunrise, Cairo at midnight, Vancouver under rain. They type not to be heard but to feel part of something vast. For once, the internet doesn't argue, it listens. The narrator's voice grows softer, slower, like breathing before sleep. In every age, it says, the sky has given us a reason to look up, and in looking up, we discover the depth within ourselves. The rogue world is now past Jupiter's orbit, fading into the soft veil of cosmic dust. Yet its story lingers in human hearts, carried through voices and signals, through screens and silence. A philosopher closes the stream with a final thought, that the cosmos is not testing us but reminding us, of humility, of wonder, of our brief but brilliant role in a vast design. When we gaze into space, he says, we are not intruding on the universe's secrets. We are returning home. And as the last frames fade to black, a quiet static hum remains. It is subtle, rhythmic, too measured to be random, too faint to decode. It hides beneath the noise, like a heartbeat buried in static. The watchers have gone to rest, their cameras turned off, their lights dimmed. But somewhere beneath the digital silence, a third signal continues to whisper, unnoticed, unwavering, waiting to be heard. And in that drifting quiet, one could almost sense that another secret was about to reveal itself. It begins in silence. The kind of silence that hums faintly, like the breath between radio waves. A slow fade from static to nothing. Then, deep within NASA's archive servers, somewhere in the labyrinth of blinking green lights and quiet fans, a file unlocks. Its timestamp matches the night the first secret memo leaked. The engineers don't notice at first. The system simply reindexes old data, one forgotten packet resurfacing like a message in a bottle from the void. The screen shows a pattern, not noise, not code, just a pulse. Perfect rhythm, steady, human, intimate. 1212. A heartbeat recorded across 4 billion kilometers. No name, no metadata. Only a file labeled signal, residual_Jovian_sequence. The narrator's tone softens, describing how this small pulse repeats inside a sea of data. The waveform curves like a breath drawn in, released, drawn again. Scientists gather around, eyes reflecting the glow of the monitor. It's not dramatic, just quiet fascination. Some lean closer, whispering theories about electromagnetic interference, echo reflections, software artifacts. But deep down, no one speaks the real thought forming in every mind. Why does it sound alive? They isolate the signal, feed it through spectrographs and frequency analyzers. It remains the same, no modulation, no decay. Only persistence. A constant rhythm against the endless static of space. Each beat soft, deliberate, like a slow tap on glass from somewhere very far away. Outside the lab, the night sky over Houston is unusually clear. The narrator's voice guides the listener to imagine it. The Milky Way stretching like powdered silk, Jupiter hanging low in the east, wrapped in a faint amber glow. The storm bands swirl beneath its clouds, their colors muted by distance but alive with lightning flashes no telescope can truly capture. Somewhere beyond that planet's reach, the rogue traveler drifts in its long dark arc. Its trajectory vanished from radar weeks ago, but somehow this pulse remains, a phantom tether between what was seen and what was lost. The sound engineers convert the signal to audible range. It plays through studio speakers for the first time. The room stills. The pattern, now within human hearing, resembles a heartbeat slowed to the edge of life. Thump, pause, thump. Between each pulse lies a breath of static, gentle and almost warm. One scientist closes her eyes and says it feels familiar. Another records it through analog tape, letting the softest wrap around the pulse like fog. The narrator compares it to the Voyager Golden Record, the greeting humanity sent into interstellar space nearly half a century ago. Hello from the children of planet Earth, the old message said. Perhaps now this was the universe answering in its own quiet way. Maybe it wasn't warning us. Maybe it was simply saying I hear you. NASA's official statement arrives the next day. They classify the pulse as artifact interference from Jovian magnetosphere reflection. The phrasing is calm, bureaucratic, and hollow. But in private channels, the researchers keep listening. They notice that the signal's rhythm slightly varies every 24 hours, mirroring the rotation period of Earth, as if it's syncing with us, echoing our motion. The narrator invites the listener to imagine, drifting closer to sleep, picturing that connection like a thread of light stretching from Jupiter's orbit all the way to your bedside. Each beat travels through space, through static, through atmosphere, until it reaches your ears. You might even feel your own pulse begin to match it. Two rhythms, one human, one cosmic, quietly merging. Weeks pass. The pulse fades, replaced by faint static that resembles rainfall. Then silence again. The world moves on, headlines change, and the rogue planet becomes another archived curiosity. But those who heard the heartbeat can't forget it. Late at night, they replay it through headphones, volume low enough that it blends with their own breathing. The narrator's voice lowers further, nearly a whisper now. In that heartbeat, some hear data compression. Others hear mathematics. A few, something emotional, an echo of ourselves sent back across the dark. The cosmos has always been vast beyond comprehension, yet this sound makes it intimate. It collapses the distance between galaxies and the quiet space within a human chest. A visualization is made for the record, a spectrogram shaped like a curved wave of blue and gold. Beneath it, a caption reads, Source, Jovian Corridor, Final Transmission. It loops endlessly on NASA's secure server, a heartbeat blinking through eternity. Outside, dawn rises over the Cape. Sunlight glints off the ocean, touching launch towers and quiet hangars. The narrator speaks softly about endings that aren't truly ends, how every signal leaves an afterimage, how silence itself becomes a message once you've learned to listen. And in the quiet closing moment, the story dissolves into calm reflection. Perhaps the rogue planet was never lost at all. Perhaps it carried a reminder that even across infinite distance, recognition can exist. Maybe the universe had leaned close for a moment, whispering not a warning but a greeting. Stars fade back into daylight. Jupiter turns beneath its swirling clouds. Somewhere, unseen, the traveler continues its orbitless drift, and within that drift a single echo remains, steady, human, fragile. The narrator's final words linger, almost sung. Perhaps the rogue was never lost. It was us, listening for our own echo in the dark.